Okay, Bismillah ar-Rahman ar-Rahim. Welcome to Lady Khadija radiallahu anha online college, live A-level maths year 2, pure maths. Today's topic is the modulus function, carrying on from yesterday. Okay, last time we were looking at what the modulus function does to a number. So something like modulus of -3, that would just be 3. So in other words, if it's a minus, then we ignore the minus. And if it's a plus, then it stays as a plus. So a couple of things you just want to learn before we go into something a bit more advanced is if we try and show that on a graph, then -3 would be, let's just go onto this side of the graph. So -3. Let's suppose that y is -3. So I can just pick on the y. Here's the y-axis, just looking at -3. It doesn't matter where I am on the x-axis just for this example, but let's pick -3 here. Then if this is -3, as soon as I put a modulus function around it, this -3 is gonna go all the way to the top. So this -3 is gonna flip up to the top here. So it's gonna become 3. So it was down here and it's now flipped up to here. If it was a positive number, so say the modulus of 1, then this would stay as 1. So nothing really happens to a positive number. So let's show that with a red circle at 1. And if I apply modulus to that, that stays there. But notice what happened to the pink. Anything that's below the below the x-axis, it came to the top. And we can just do another one just to make sure you've got the point. Let's go with modulus of -1, and that would become 1. And we'd see that. So anything that's -1, it would then, with the modulus function on it, it would flip up to the top and you'd have it come up here. So what you see is that anything below the x-axis flips up to the top. And now we want to apply that and show how you can draw a graph of a modulus function. So we're working through the Pearson book at Excel A-Level Maths Year 2. And the question is in example 3, sketch the graph of y equals 3x minus 2. You should be comfortable from GCSE plotting the graph of y equals 3x minus 2 if it was without the modulus. So if it was just y equals 3x minus 2, you should be comfortable. We want a graph that goes up for every 1 square across. It goes 3 squares up and it continues doing that. And we also want it to pass -2 on the y-axis. So this is the kind of graph you would have done at GCSE. Let me just extend that. And if you've got a graphical calculator, then in the exam you can use that to help you. But that's about as far as you took it at GCSE. Now what you want to try and do is think about the modulus function. And if we put a modulus function around that, what does that mean? What it means is that for any answer we get for our y coordinate, any negative would get dropped, and we would just be looking at the positive. So when I say dropped, I mean the -3 we were looking at before, it just became 3. We dropped the negative. So the same would happen to the graph, that if this graph goes into negative territory, then all these negative points, we would drop the negative and change them into positive. So that the way that works is just like the dots we had before, they flip up. So I can show that if I flip this like that, and that's what you'd get. It would flip up. So anything below the x-axis just gets flipped up, and you can carry on the line from there. So in red is the flipped up part of the line. Okay, and that's how we sketch a graph. Very, very basic technique. You just imagine the graph to begin with, and then you flip it up. Okay, the next one we want to just try and actually solve an equation. So the next example 4, is we want to solve the equation 2x minus 1 modulus. The modulus of 2x minus 1 is equal to 5. So we're going to use the graph to help us because we want to picture what that function looks like. We know what 5 looks like. 5 on the y-axis is going to be here. So we want to know at what point does the graph intersect the y equals 5 line. So let's begin with 2x minus 1. Can you tell me anything about where this is going to cross the y-axis, the original graph of 2x minus 1? How steep it's going to be for every one square across? How many squares does it go up? Okay, let's start from the one square across, 2 squares up because of the 2x, and we'll just extend that. And then we want it to cross at -1, which is here. Okay, that's pretty good so far. Probably just want to extend that as well. Okay, and now comes the modulus part. So this is at the moment the graph of y equals 2x minus 1. That's from GCSE. But how do I flip that? I have to look at where does it go below the x-axis, which is here. And that's the part I want to flip. And then we can bring it up to the rest, join the rest of the graph above the x-axis. Just want to redraw that line y equals 2x minus 5. I mean the y equals 5 line. Good, and there are your two solutions that we need to find. So we need to find this one, which we can just read off. That looks like the point 3. The numbers are a bit weird on this graph, but that's 1, 2, 3 across. So x equals 3. And then this one looks like it's -2. Let's check that using the algebra. So we can split it into 2 because we know that when x is positive, then the modulus doesn't have any effect. So we can say for x is bigger than or equal to 0, then the equation just looks like a normal equation, which we can deal with. So taking the -1 across, 2x equals 6, x equals 3. So that's this one. And then we can do the same thing, but remembering that when x is less than 0, when x is a minus, then we minus the minus. So that's how we get rid of the minus. We turn it into a plus. So that's like minusing the minus. So I've just put a minus in front of the equation to account for that. So if you're not sure about that, just remember if the examples I did earlier, so minus 3, modulus of minus 3, that turned into 3. How else could I have done that? Well, I could have just put a minus in front of the minus 3, and that has the same effect. So if I want to try and write the modulus function without the modulus sign, I can just put a minus in front of it. But that only works for where you're using negative numbers. So it's for x is less than 0. Okay, expand those brackets, and it's minus 2x plus 1 equals 5. Rearrange, and we've got minus 4. So let me just make it easy for you. My minus 2x equals 4, and then x equals minus 2. Okay, a couple of quite difficult things there that you might find difficult the first time. Hopefully they'll become easy to you, but let's just see how you did. If you're there right now, we want to solve the equation. How did the graph help? Can you write down what do I do first when I'm trying to sketch the modulus function? Good. Everything below you flip. So the easy one is the y equals 5. There's no modulus there. But you imagine the 2x minus 1, and now we, like Aisha said, we flip it anything that's below the x-axis. So that gets flipped. Good, that's a flip done. Okay, next we circled the intersections, but then to find them using algebra, how did we begin that? Okay, you'll remember it's very easy to start off with. You just look for the cases where x is positive. So that means it's just a normal equation. 2x minus 1 is 5 because as long as the answer is positive, then then the modulus function doesn't have any effect. And then for x is negative, we have to put a minus in front, and we can expand the brackets and get the answer. Just a correction, it's not that for x is bigger than 0, it's for the whole thing is bigger than 0. So for 2x minus 1 being greater than 0, as long as what's inside the modulus ends up to be bigger than 0, then the modulus has no effect, and we can just treat it as a normal equation. Same thing here. It's not whether x is less than 0, but whether the whole thing inside the modulus is less than 0. Okay, join me again